In the race to conquer space, rocket engines are the heart of every mission. The farther you want to venture into the cosmos, the more powerful your engines need to be. Recognizing this, SpaceX has laser-focused on developing and perfecting the next generation of their rocket engine, the Raptor 3, which promises to be the king of all rockets. So, how powerful is this engine, and how does it outperform all other ones? Before we find out the answers, don't forget to subscribe and hit the like button to stay updated. All right, let's dive right in. Raptor 3 represents a giant leap in rocket engine technology. Designed to lift the 150 meters tall Starship into space, it delivers extraordinary power without disappointment. Let's talk about raw power first. Raptor 3 generates an astonishing 280 tons of force at sea level and 306 TF in a vacuum. This means both versions have a 50 TF increase over the Raptor 2 currently in use. Furthermore, Musk revealed that this new engine not only has higher thrust, but also boasts a better ISP. This is a remarkable achievement. Let me explain. Thrust, the force an engine produces to propel the rocket upwards, depends on the amount of propellant flowing through the engine. Meanwhile, ISP measures how efficiently the engine uses propellant to generate thrust. Normally, there's a trade-off. Increasing ISP usually means reducing thrust and vice versa. However, Raptor 3 breaks this rule by increasing both parameters simultaneously, creating an engine that is both powerful and fuel-efficient, a feat of rocket engine engineering. To achieve this, SpaceX has pushed the limits of materials and manufacturing techniques to the extreme. They have increased Raptor 3's combustion chamber pressure to an unprecedented level, 350 bar. Wow, let me help you visualize. The pressure the combustion chamber walls endure is like placing the weight of 17 Statues of Liberty on a single square meter. The fact that Raptor 3 can withstand such pressure without failing is a testament to its exceptional resilience. But perhaps the most impressive thing about Raptor 3 is its appearance. When you look at this design, you can't help but marvel at its unexpected simplicity. In a field where complexity is often the norm, with countless pipes, valves, and auxiliary systems, Raptor 3 presents an extremely minimalist beauty. Make no mistake, this is not an unfinished or basic design. On the contrary, it's a complete engineering masterpiece capable of producing enormous thrust without breaking any physical laws. The simplicity of Raptor 3's design is not just an aesthetic achievement, but also a breakthrough in manufacturing. It allows for faster production, minimizes potential failure points, and enhances the engine's overall reliability. Raptor 3 is a vivid demonstration of SpaceX's design philosophy. Simplify to maximize efficiency. It shows that sometimes less really can be more. When you look at Raptor 3, you might wonder, where did all the complex piping go? Elon Musk revealed that Raptor 3 integrates most of the external pipes and manifolds seen on Raptor 2 into the walls of larger components. But it doesn't stop there. Musk boldly switched from bolted flanges to weld. This is not a random decision. Bolted flanges are heavier, require more complex manufacturing processes, and increase the risk of leaks or failure. To produce Raptors quickly and cheaply, switching to welding is a brilliant decision. The result of these improvements is an engine that looks surprisingly simple on the outside, with more complex internal components. However, this change is not just about aesthetics. It revolutionizes the assembly process. Instead of installing thousands of small parts, engineers now only need to assemble a few large sections of the engine, saving significant time and effort. That's just the tip of the iceberg. Integrating the piping serves a much more critical technical purpose. Raptor 3 employs a regenerative cooling system. The engine is cooled by the cryogenic fuel line, a clever design that allows the fuel to cool engine components while also preheating the fuel before it enters the combustion chamber, increasing combustion cycle efficiency. This is a perfect example of how SpaceX optimizes every aspect of the design for maximum efficiency. But the benefits don't stop there. With this efficient cooling system, Raptor 3 has completely eliminated the need for an engine heat shield. Elon Musk shared on X, taking away the engine heat shields also removes the need for 10+ tons of fire suppression behind the engine heat shield, as any gas leaks simply enter the already superheated plasma surrounding the engines, rendering the leaks irrelevant. Honestly, Starship is struggling with its dry mass. Removing the heat shield not only significantly reduces the mass of each engine, thus reducing the overall dry mass, but also frees up precious space on the booster skirt section. This means that while maintaining the 9-meter diameter, the booster can now accommodate more engines. In the version of Starship using Raptor 3, Starship V3, SpaceX plans to install up to 35 Raptor 3 engines. This is a significant leap in the number of engines, aimed at providing the necessary thrust for Starship. Well, we recently made a video about the configuration of 35 Raptors on Starship V3. Check it out if you want to dive deeper. It's packed with fascinating details. The specifications show that the Raptor 3 is a miracle in itself. But is it the king of engines in the entire industry? To prove this, let's compare it with the most robust engines out there. When it comes to rocket engines, thrust is always a key metric. Look at its biggest rival, Blue Origin's BE-4. When Raptor 2 debuted, the community was still debating whether BE-4 or Raptor was the king of engines. Well, you can't deny that BE-4 is a truly powerful engine with 250 TF of thrust, but it's too complex and bulky. Not to mention, while Blue Origin has only flown BE-4 once, SpaceX has developed its third-generation engine. When Elon Musk announced Raptor 3, comparisons to BE-4 almost ended. Raptor 3 has superior thrust over BE-4 while being a fraction of the size and mass. What about the RS-25, the engine that powered the iconic space shuttle? Each RS-25 produces nearly 190 tons of force, an impressive figure. But it seems to have been left behind by Raptor and the F1 engine of the legendary Saturn V. With 690 tons of thrust from a single engine, the F1 is indeed a marvel. However, it is a miracle from 60 years ago. The F1 is a rather conservative design from the early space age, with a combustion chamber pressure of just 68.95 bar and a turbopump running at 5,500 RPM. It generated thrust through a massive, cumbersome nozzle design. In contrast, Raptor 3 achieves a combustion chamber pressure of 350 bar. Look at this. Raptor 1 was at 250, Raptor 2 reached 300, and the Russian RD-180, operating at 267 bar, was the next highest. 350 bar is just spectacular. Moreover, Raptor 3's turbopump operates at over 30,000 RPM, 5.5 times the speed of the F1. While the F1 was designed to generate enormous thrust for the Saturn V's initial stage, SpaceX aims to use multiple Raptor engines to create a total thrust while focusing on reusability. However, when evaluating rocket engines, one critical metric to consider is the thrust-to-weight ratio. The RS-25 of the Space Shuttle achieves 73.1, the RD-180 reaches 78.1, the BE-4 about 80.1, and the F1 achieves 94.1. Based on information from Elon Musk and previous analyses, Raptor 3 is expected to weigh around 1.5 tons. This allows it to achieve a thrust-to-weight ratio of up to 186.1, far surpassing all the engines mentioned above. Remember when Musk said he wanted to produce the Raptor engine for $250,000 each? Sounds crazy, right? We're talking about rocket engines, not luxury cars. But he has successfully reduced the production cost of the current Raptor from $2 million down to about $1 million per unit, approaching the production cost of a Merlin engine, which is incredibly cheap compared to any other rocket in the industry. Musk said that Raptor 3 would be the subject for scaling up production. So once mass production kicks in, and economies of scale are realized, achieving the goal of reducing production costs is just a matter of time. Looking at other engines, in reality, there aren't many rockets and rocket engines capable of reuse at the moment. This means they're essentially throwing away tens, if not hundreds, of millions of dollars with each launch. At present, SpaceX is focused on producing engines solely for its own missions. Elon Musk has no plans to market them to other entities, which is perhaps a relief to competitors. Priced at $250,000, a Raptor engine's ability to be reused numerous times offers significant cost savings. If SpaceX were to offer the Raptor externally, it could potentially dominate the launch vehicle market and slow down the competitive and developmental pace of the whole industry. Without a doubt, Raptor 3 represents modern rocket science philosophy. Once Raptor 3 makes its debut, it will instantly become the king of all rockets. What are your thoughts on this engineering marvel? Let's kick off a discussion in the comments section below. I'd love to hear your insights and predictions. All right, that's it for today. Thanks for watching, and we'll see you next time.